I will try. All right, here's the notes. Bust out your notes. Get it ready to go. Okay, so according to my screen, it says that we were done with graphing. We just did not finish defining, right? The inverse? Yeah, okay, so let's do it like we always do. What do you write? X equals what? Secant of y. Okay, solve for y, so y equals, which is as an inverse notation, we use f inverse of x, equals what? Okay, arcsecant or secant inverse of x, okay. Like Ashley said, you can also use arcsecant, bless you dear, of x. It's really up to you. What is the domain of secant inverse? What is the domain of secant inverse? Nick?
Non-inclusive negative infinity, so negative 1 inclusive, and then u inclusive 1, comma, positive infinity, non-inclusive.
Do you guys agree with Nick? Yeah? Okay, maybe, right? All right. Then I'm going to ask for the range, okay? All right, Jason and your team, get ready to answer the range. All right, Isabel, are you the rep for your team? Or Jason? Oh, okay, Jason.
Okay, I guess we'll do the range of the domain of the other functions 0 to 5.
Do you guys agree, Jason? All right, I'm going to rewrite it this way as well so you can see the difference. Can I write this way? Yeah? Yes, you can. All right, let's graph it out. How far should we label?
1.
Okay. When we're graphing this, it's the Moses pi, so we're going to go to the Moses pi. Yeah. Up pi, left negative pi, down negative pi. Bless you. It's an interesting day. Okay. Are we ready? Shh. Is it just me?
So gross. It smells like bad tomato soup.
Hey Jan, this is Angie in D6. Can I have someone come to my room and smell something? Thanks. Bye.
We're going to pretend that it's not smelly. And they will investigate our smell. Okay.
All right, we're gonna pretend that this is normal, a normal Friday. Oh my. I'm having a hard time concentrating. All right, there's a half mark. 1 is a third of its distance. I'm gonna go 1 here, -1 here, and -1 here. Fine. Asymptote, let's start with those. Where should we graph the asymptotes? Where should we start with asymptote? Right, exactly, pi over 2, right? Okay, I have 2 dots to make. What's your first dot? The normal right now, yeah. It's always easier to do the normal first and then reflect. 0, 1? Okay. 0, 1. And then the other dot is pi comma -1. Okay. Curvature away from the asymptote or towards it? Towards it. So there's the normal. Then I need to now graph its inverse. So I'm going to write the orange one is y equals my normal restricted. So y equals secant of x restricted, okay? So blue, let's start with the asymptote again. Where? Y equals, right? Y equals half. Okay. Dots. Where should we put the dots? 1, 0. So 1 is here. 1, 0. Okay, yeah, 1, 0. What else? -1, pi. Right? Now, if you are unsure of what direction you're going, hi, let me know what you smell. So this is the line y equals x. Let's do the reflection. I have the 2 dots and I'm not sure which way I will go. So if you have to make it symmetry to this line, where are you going to go? Let's talk about the top dot, okay? Which way are you going, right or left? Left, okay. Yeah. Okay. Then the bottom dot to the right. All right. Okay. And someone asked me, hey, you know, we have to graph the inverse function, do I have to draw its original? No, you don't have to draw its original. For the notes purpose, I draw all of them, okay? Okay, as you know, normally I would say, hey, what quadrants is the inverse in? So what quadrant do you think secant inverse is in? First and second. And when I'm saying quadrant, would you agree that I'm back to the unit circle? Yeah, so we're going to go 1 and 2. Okay. Nick? These? No. Because remember, we can't repeat. The period, the meaning of the definition of the period, it's how far do you go before you repeat, but we can't repeat at all. So we don't care. I would never ask you an inverse function to begin with. Yeah. Okay. Last function of inverse. Whew. Cotangent. Let me give you 2 minutes to kind of talk to one another of how to start. Can you graph a pi to the right and a negative pi to the left? Okay.
I kind of remember that part. Let's put 1 over all the y value. Y equals secant of x. Yeah. Yeah, yeah. So you just tangent goes, tangent goes up this way. And that means there's an angle. No, we're not. We're graphing cotangent. Yeah. So if tangent goes up this way, cotangent is going to go up this way. Cotangent is tangent. Yeah. Yeah, like that, yeah.
What did you guys do? Okay, we will start with points, okay? I will have 5 points. There you go. 1, 2, 3, 4, and 5. We're going to start with input 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay? All right, let's start. Cotangent is what divided by what? 1 divided by tangent, or? No, cotangent is not the inverse of tangent. Cosine divided by sine. Beautiful. Here we go. Are we ready? Jack! Cotangent at 0. Undefined. Is he okay? Yeah? He's right. That is true. Okay. Danielle, L. Cotangent pi over 4. Yes, it is. It is a Friday. Megan, cotangent pi over 2. Oh, it's asleep. Perfect. Nice job. Are we like unsure about these outputs?
Wait, doesn't the 0 with the cross through it mean? Oh, that's undefined.
Undefined, yes. Yes, sir. Now, Liz, cotangent of 3 pi over 4. -1. Beautiful. Nicely done. And last one, cotangent pi. Yes, sir. All right. Okay, here we go. I need asymptotes, asymptotes. Okay. Pi over 4. Are you guys okay back there? Okay. 0, negative. Okay. Okie dokie. All right, Justin. Is this a 1-to-1? No. Okay. Because Justin says no, we have to cut it. So it can be a 1-to-1. Okay. You have been invited to a meeting. Are you ready? Okay. Nathaniel, you are in a group with mathematicians. You have to cut this off. Where do you want to cut it off so it can be 1-to-1?
0 to pi.
Yes. Accept. 0 to pi. Non-inclusive, right, class? Yeah. Then we are now going to define it. Here we go. X equals cotangent of y. Am I going too fast? Okay.
Okay, solve. Y equals f inverse symbol of x equals cotangent inverse of x. Just like in algebra 2 trick, I will also accept cotangent of x. Okay. Then we are going to definitely define the domain of cotangent inverse.
We do this every time.
We do it every
We do it
time.
on tests, like, we just-
Okay? No, I just need you to know so you can find the values. Right? Can you find the values if you don't know the domain and range? No, you don't know where it goes. Okay? It's like us driving around without our navigation system. All right, Cade, what is the domain of cotangent inverse?
0, pi, non-inclusive.
0, pi, non-inclusive of the ends. Is he right for the domain of cotangent inverse? Josh says no, but it's more like a question mark no. Yes or no? No. The domain of the inverse is like the range of the regular, right? What's the range of the regular? That's right. Negative infinity to the infinity. Nice job. Then now, Cade, what is the range of our cotangent inverse? Yes. Okay. I'm sorry, over pi. Oh my gosh. He said pi. I just wasn't listening. Or this. All right. Quadrants. Okay. Is it 1 and 4? Is it 1 and 4? No? Is it 1 and 4? So let's look. Is it 1 and 4? 0 to what? Because as you know, more often I would just say, hey, you know what, 2 quadrants, it's cotangent inverse in. And you would say 1 and 2. That's right. Okay. Let's recap, okay? How many of the cotangents are in 1 and 2? Let's name them. 1 and 2, restriction. Restricted in 1 and 2, quads 1 and 2. Cotangent inverse for sure, right? What else? We just did one before that, which is secant inverse. What else? And then cosine inverse, those 3 of them. That means how many are in 1 and 4? Tangent inverse, sine inverse, cosecant inverse. So guess what? The 3 and 3. Right? Okay. Now graphing out the cotangent inverse, I'm going to have to do it twice, 2 different ways. So you can see how we can get cotangent inverse differently. Okay. So the first one, something on my eye. The first one, when I do it normally, we are just going to go from 0 to pi. 0 to pi, 0 to pi, 0 to negative pi, and 0 to negative pi. Half pi is right in the center, but 1/3, 1 is a third of its way. So I'll just write 1 right here, negative 1 right here, negative 1, and negative 1. Okay, so those are my negative 1 marks. So again, we're going to graph out the regular cotangent first, and then just reflect it. So the regular cotangent have asymptotes at 0 and where else? Pi. Okay. Then I'm just make my dots. Here we go. 1/4 pi over 4 go up to 1, right, class? At pi over 2 goes to 0. At 3 pi over 4 goes to negative 1. And then here's my regular cotangent with restricted domain. So y equals cotangent of x. Now I'm going to draw its inverse. Should we start with the asymptotes? Sure. Where? Pi and where? And 0, right? At the x-axis? Good. Similarly, I'm going to need you to plot in 3 points. What's your first point? Pi over 2, 0.
So pi over 2 is right here. Would I say here? No, okay. That was pi over 2, 0 though. So how would you switch that? 0 comma pi over 2. So wouldn't that be right here? Yep. Now what? 2 more points. 2 more points. 1 comma pi over 4. Okay, so 1's right here, comma pi over 4 is right here. 1 more point. Negative 1 comma 3 pi over 4. Okay. And I'm going to turn my paper sideways because I can't really draw nicely if it's... I'm not a very good drawer, grapher. Okay. There you go. Now, if I were to draw this line, this beautiful line called y equals x, do they look like they may be symmetrical? Yeah. Okay. So which one's the inverse function, the blue or the orange?
Red.
The red. Okay. Orange, red, whatever your color is. Now I'm going to do another one using cotangent inverse to see the relationship, okay? So down the bottom, don't graph it yet. I will give you plenty of time to graph. I just want you to pay attention. We will graph out tangent inverse first. So this is pi, this is pi, this is negative pi, this is negative pi. Okay. Tangent inverse, can someone tell me, where do we start? Do we have asymptotes in tangent inverse? Yep. Where? Where were the 2 or 1 asymptote? Pi over 2. Horizontally or vertically? Horizontally. So here's pi. So pi over 2 is right here. Okay, just pay attention, and then I'll give you plenty of time. I'm graphing out tangent inverse, okay? Now, what are the dots for tangent inverse? 0, comma 0. Is that okay? Yeah? Okay. Would that be an okay dot? I'm just asking. Make sure we're on. Yes or no? Ben? Yes, okay. Another dot.
I was gonna say,
Should I have another asymptote somewhere in there? Yeah? Where's the other asymptote? Probably if I, huh? 0 pi, 0 up pi, like here? Up there? Not an asymptote. A dot, you mean?
Yeah.
Chase? Okay. So Chase said there's a dot, 0 pi. Is that another one? That doesn't look like a function with the 2 dots. Yep.
Your asymptote should be at y equals negative pi over 2.
Y equals negative pi over 2. Do you agree with Patrick? Yeah, yeah. If I put in 2 asymptote, you guys would probably have a better.
Patrick,
bye, Patrick.
Ben.
1, so negative 1, negative pi over 4.
Yes, I will accept. Okay. Then 1 is positive pi over 4. All right, so here's your tangent inverse graph.
Wait,
I'm sorry. Y equals. Is that okay so far?
I think it's backwards.
Yeah? No? Maybe?
No.
I'm just asking. Does it look like what your notes should have?
Yeah.
Okay. Now look at the orange. Look at the orange, red, whatever color you think it is. How can I use this tangent inverse and make it to look exactly like the red/orange color? First, what can I do?
Make it negative.
Make it negative. What do you mean? Make what negative?
Reflection about the what? Yeah, can I take a reflection about the y-axis? So here we go. I'm going to sketch it out. What that means is whatever's on the right is now on the left, and whatever's on the left is now on the right. Okay, don't sketch.
Can you make the x or y line negative or just the y?
Okay, so we're going to do one at a time, okay? So if I make the reflection over the y, is now y equals tangent inverse of, beautiful. It's kind of now in the right direction, but is it the same spot? No, what else you to do? Bring it up. How much up? Pi over 2, which one? Pi over 2. So that means this dot is not here, right, y'all? This dot is not here, and this dot is here. So check this out. Sorry, sideways. Okay, so do you think that should be like cotangent inverse? Yeah. So I brought it up by a pi over 2. So what do I do with that? Add outside pi over 2. Okay. Now tangent inverse or tangent, is it an odd function or an even function? Tangent? It's odd. So if you have an odd function and if it's a negative angle, what can you do? Put it on the outside. So it's like negative tangent of a positive x plus pi over 2. Now, this is the equation that you can get if you are asked to find cotangent inverse. Now, as you know, most book probably does not like that negative in the front. So if you see this, okay, they can also move the pi in the front, pi over 2 in the front. Can you see this? Minus tangent inverse of x. Okay, that's all the same. Okay, so this is one way of getting cotangent value. Okay, and we just proved why that is the way that is. And there's another way that I will demonstrate when we do some examples. Okay. Any questions on that at all? Do you guys see how that turns into? Yeah. All right, example, exact value. Calc or non-calc? Non-calc. Non-calc. That means it's all in the brain.
30 degrees.
Oh, it's 30 degrees. Is that answer correct for A, apple? That's fast. Cosecant inverse of 2, what's the exact answer? Okay. If you don't know how they came up with it, I don't know the answer either, to be honest. I'm going to give myself a box. I don't know the answer, but that's what I'm going to put my answer. Okay. I'm not quite comfortable with cosecant inverse yet, so I will use cosecant of my box. Is that okay? Are those two equivalent?
Yes.
It's Friday. I can't think in terms of cosecant. So I'm going to use what? Yeah, I'm much more comfortable with sine at times. Right? It's Friday. Fraction looks so scary. I'm going to flip this side. If I flip the right, I need to flip the left. Yes, Patrick?
Can you just call the box X?
Whatever you want.
Okay.
No, it has to be a box.
Yeah, it doesn't have to be a box. I just... All right, so a few of you did mention earlier that this box gets a value of 30 degrees, pi over 6. So guess what? That's how we get it. Okay. Do you think you have a button of cosecant inverse on your calculator? No, you don't. So when you are able to use a calculator, do you punch in? Let me ask you. Cosecant inverse of 2. Do you punch in 1 over sine inverse of 2?
No.
Oops, what do you punch in?
Sine inverse of 1/2.
Yeah, can you guys see that right there? It's sine inverse of 1/2.
Because on the inside it's just hypotenuse over opposite, so then you can just flip it for sine and the opposite of hypotenuse.
That's right. Okay, and this is a wrap for right now.
The wrap?